Okay. Hi guys, hope you are well. So today I'm going to be going through an AS Year 12 differentiation question, but this time is a very specific one from first principles. Now, as an exam question, certain words should prompt certain formulae, certain methods, for example. And by this I mean, as soon as I see the word first principles and derivative, first principles, derivative, I instantly think of the formula f dash x or f prime x. F prime x means the derivative. It's like dy over dx. It just means the derivative. So f dash of x equals f of x plus h subtract f of x over h as the limit h approaches 0. That is the formula for the derivative of any function that's in terms of x. Now, some people may use delta x or whatever. H is just meant to represent a very, very, very small value. So you can use any notation you use, but I typically use H. This is given to you in the formula book, but for fluency's sake, you should memorize it, in my opinion. This should be a free mark. F of x plus h means we replace the input of x with x plus h. Now I'll demonstrate what this means next. So, let's start with the question. In this scenario, f of x equals 2x cubed. Because that's the function, the original one. We want to get to the derivative of 6x squared. So if I know f of x equals 2x cubed, f of x plus h means replace all x terms with x plus h. Replace all the inputs of x with x plus h. So this means replace all inputs with x plus h. The input in this case is x, so replace x with x plus h. Okay, so this would equal 2 bracket x plus h x plus h cubed. Now let's expand that out. 2. Now in this scenario, you would use the binomial expansion, in my opinion. Or you could expand it out like this. Either way is fine, but I'm going to use the binomial expansion. And the reason I'm saying this is you'll see now. So, bracket. I'll put a massive bracket here. X cubed plus 3x squared h plus 3x h squared plus h cubed. Now, if you're wondering how I got from here to here, is through using the binomial expansion, and I'll demonstrate that here. So in the binomial expansion, if I had x plus h cubed, this would equal 3c0 times x to the power of 3 times h to the power of 0 plus, because the binomial expansion is summative, you're continuously adding terms, plus, that's term 1. So that's term 1. Or the 0th term, we call it in the binomial expansion, plus 3c1 times x squared times h to the power of 1 plus 3c2 times x times h squared plus 3c3 times x to the power of 0 times h cubed. Now, a thing you should notice is 3 means the third row of the binomial expansion. If you remember, the binomial expansion is 1, 1, 1, 1, 2, 1. This is the third row. Where all these 1 starts, that's what we call the 0th term. This is the first term, this is the second term, this would be the first term. This represents 3c Actually, replace that. 1, 3, 3, 1. This is the third row. Now the reason that's the case is because this is actually the 0th row. The way I like to remember it is x plus y to the power of 0. Anything to the power of 0 is 1. So whenever you see a 1, you should instantly think 0 on the left, 0th term. These are all the 0th terms of the respective rows. So this is so that's the first row. This is the second row. That's the third row. That's 3C0, 3C1, 3C2. Now something you should also notice is the symmetry of the binomial expansion. 3C0 is the same as 3C3. 2C0 is the same as 2C2. So whenever we're choosing the 0th term or the nth term, in this case, they will always equal to 1. Now you would punch that all into your calculator and you'd end up simplifying to this. Hopefully that makes sense. Now it's important for the first maybe like 6 rows, I would say memorize the binomial expansion, but that's only for fluency's sake. Here, I'm not doing it as an exam style, so exam pace. I'm really breaking down each and every step so it makes sense. But the binomial expansion itself, writing this out, gets you the exact same amount of marks as going straight to this. So there's no point really going the long-winded way. So now let me copy and paste this. So we've expanded out x plus h cubed. So that's f of x plus h. That simplifies to 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed. Now instantly, the question wanted x squared, 6x squared. I see a 6x squared here, so I know at the end of it, I must be left with this term somehow, with a h factorized. This is what we call reverse engineering. It's using the answer to help guide the process. So that's fx plus h, f of x equals 2x cubed. Now let's start what f prime of x is. We've done all the setup necessary. Let's start the question. Now we sub into the formula. The formula was f of x plus h, subtract f of x over h, limit h approaches 0. This is a crucial step. Never forget it for each of your steps, because some examiners are very stingy with it. So now let's substitute. So f prime of x equals, substitute what I know. So fx plus h is this, 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus f of x, which is 2x cubed, over h. Now one thing I notice is this and this cancel out. So as limit, remember, limit h approaches 0. So now we get left with this. Now a thing I instantly recognize is the h's. Remember, I want to end up with this term on its own. So let me factorize out the h's so I can get that 6x squared on its own. And because factorizing is useful, so h bracket 6x squared plus 6xh plus 2h cubed over h. The h's cancel, which leads me to f prime of x equals limit as h approaches 0, 6x squared plus 6xh plus. Now the final step is, we have said that the limit as h approaches 0. So think of it So think of it like this. H is going towards 0. It's getting smaller and smaller and smaller and smaller. So imagine this, a number line. H is a really small value. So this is 0. This is whatever number. I don't care, question mark. H is somewhere here. It's really, really tiny. That's the point of H. Really, really tiny. Now, with limit H approaches 0, this means that we're trying to make H smaller and smaller and smaller and smaller and smaller. We're trying to make H tend towards 0, get really small. But at some point, the whole point of this is to make H equal to 0. The way I like to think of it is like this. You have 0.9 reoccurring. That's 0.999999999. As we keep writing more and more 9s, eventually we'll write so many 9s that'll equal to 1. And you might be thinking, that doesn't make sense. 0.99 reoccurring is not the same thing as 1. But it is. And this is the beauty of limits. 0.9 reoccurring is the same as 1. And the reason being is this. What's 1/3 equal to 0.3 reoccurring? If we multiply both sides by 3, you will get 1 or 3/3 equal to 0.9 reoccurring. What's 3/3? 1 is equal to 0.9. This is an example of a limit. Even though, like, logically it doesn't make sense that 0.9 reoccurring is equal to 1, we made it equal to 1 because it does equal to 1. That's the same point with here. Even though H we don't think can approach 0, because if we make H equal to 0 here, you get division by 0, which can't happen. This is why we put a limit. It's a fail-safe. It's so we can technically divide by 0 even if we can't. That's the whole reason this limit bit is important. So now, because we've cancelled out the H's at the bottom, there's no need for the limit because the whole fail-safe has gone. So now, what we say is as H approaches 0, because that's the whole point, what happens to this term? What's 6? This becomes 6x squared plus 6x times 0 plus 2 times. These terms cancel out, so they just become 0. So f prime of x equals 6x squared. And that's the answer. That's how you do this question. Just remember, these limits are like fail-safes. They're like fail-safes. The whole point of this limit is to prevent the complication of this division by 0. Because they technically say dividing by 0 opens up a black hole. Whatever you think, just you can't divide by 0. That's why we introduced this limit as H approaches 0. Because we're saying H is technically approaching 0, but it isn't. But as soon as we've gotten rid of that complication through this step, we don't need this anymore. It's irrelevant. So we remove it and we say, you know what? Instead of H approaching 0, let's make H approach 0. So like this. So it is equal to 0. Because that's the whole point. And there you go. F prime of x equals 6x squared. Hopefully that made sense. If you have any questions, please feel free to comment below.